Hello. So first, let's look at three-dimensional coordinate systems. So these are just some crude drawings that aren't maybe 100% accurate, but they're a pretty attempt at what's trying to be conveyed. Most important thing is that you understand some of the wording here used. The first one is pretty simple, just a line, it would represent probably a line through the point. Would be the best option we'd probably have for this. Parallel to the z-axis, basically it's a xy plane line, 2, 3, x equals 2 and y equals 3. This one, y equals 0, z equals 0, basically is the x-axis because it's the set of points that can only lie where those are the conditions, z equals 0 and y equals 0. So those points would have to be the x-axis. And x squared plus y squared plus z squared equals 1, where x equals 0. Well, if all three coordinates are in place, then it's a sphere, but two coordinates in play means it's a circle. And y squared plus z squared equals 1 is a circle in the yz plane with radius square root of 1, which is equal to 1, of course, and a center of 0, 0 to center in origin. Because the formula for a circle is simply whatever two different variables minus the y0 or z0 here, like the center thing, but with y squared and z squared, there is none of that subtraction going on. Or it's 0 in this case, because z minus 0 squared is the same as z squared. It's the same as y minus y0 squared is y squared. Y minus 0 squared is the same as y squared. And a squared is, of course, your radius is a, so you have to square root whatever you have on the right-hand side of this equation when you have it in standard form. But it's a standard form, as you know from algebra, more than likely. So here's another equation to be given: x squared plus y squared plus the parentheses z plus 3 squared equals 25, and z equals 0 in this thing we're given. So yeah, you basically simplify it down. You can like terms, you add you get your like terms together, combine them. So 9 on one side, 25 on the other side. You can subtract 9 on both sides. You get the formula x squared plus y squared equals 16. And this can be wrote as x minus 0 squared plus y minus 0 squared equals 4 squared. So a circle in xy plane's radius equals 4. I'm kind of doing a little bit more than they might, an acceptable answer might be a little bit simpler by making sure you understand this radius idea as well as the center. This would be centered at the origin yet again because of 0, 0. Y equals x squared, z equals 0. Yeah, I think it's pretty self-explanatory. I tried to draw this since, these circles are pretty simple. They're going to be in a plane, one of the planes, so you can picture that yourself. Just give you an idea, it looks weird in 3 dimensions. A 2D, you're trying to do this 2D drawing in 3D, it's very, very, at least a 3D drawing, you could sometimes make it look pretty decent. But this is trying to do a 2D in the 3D plane on a 2D paper, so yeah. It's really, but the parabola, it's going to look pretty weird. That's kind of what would be though with x and y axis, with z being through the paper. But yeah, parabola, just a parabola y equals x squared in xy plane though. We've seen these, you've seen these plenty of times in other math courses. Okay, now these two inequalities are relatively simple, this type, this one especially. So if z equals 0 for these two, it's just that we're changing what x and y, if x and y are positive, basically, what is represented, what are all the points? Well, it's the first quadrant of the xy plane. But if x is positive, y is negative, and z is 0 again, this is the xy plane, but it's the fourth quadrant. Because we call this two positives, first quadrant, second is negative, positive, negative, negative, and positive, negative. Basically, it is xy planes and z equals 0. So this equation, x squared plus y squared plus z squared, is less than or equal to 1. We know the standard equation for a sphere would be x minus x 0, so we know this whole thing. You can read it, but it's equally as good, similar to a circle but with 3 dimensions. So what we call this, if one of the official terms is the ball of radius 1 centered at origin, since it's the inside plus the it's inside up to the boundary, so it's like a ball, a solid ball you can bounce around, basically, like a bouncy ball or any type of ball. Basically, it has it's filled in as a villain. Or you can say this is the sphere of radius 1 plus its interior. Same thing. And I even have a picture here that shows the red being that, and the pink here is the next part B. Basically, when it's just greater than 1, this is all points outside sphere in A. So it is all points more than 1 unit from the origin is a fancy way of saying that. The proper way. But yeah, you can see basically it's all points inside in A and all points outside. Basically, all inside and including this way. In this one, 1 is less than or equal to x squared plus y squared plus z squared, less than or equal to 4. We just see this just because it's more interesting, it can actually be. So this is basically, you have a sphere of radius 2. It's basically, it includes up to that point the sphere, and it's the ball. But, yeah, it has like a hollow inside. Its inside is hollowed out. Basically it's removed. The ball of radius 1 is removed, while this is the ball of radius 2 centered at origin. While the ball of radius 1 centered at origin is removed. That's one way of saying this. And real quick, basically, x squared plus y squared plus z squared less than or equal to 1. But z is greater than or equal to 0. You're going to get a hemisphere. Basically, it's a hemisphere. I'm not going to try to draw this out. It's very hard to draw a 3D sometimes in this I'm drawing, but it's half a sphere, hemisphere. But these two are very quick to say. Z, basically, if you have this lab bounded by the plane z equals 0 and z equals 1, can be, it can represent that by just 0 less than or equal to z less than or equal to 1. And half space consisting of the points on and below the xy plane can be represented by z less than or equal to 0. I think that 37 is somewhat, it's everything that's below the xy plane, so basically it's everywhere that z is negative because it's below that. It's one way if you think about the 3 different dimensions that we have here. Very hard to visualize, though. I can understand that. Just to get an idea. So finding the distance between points. Time for some actual just direct formula application now. The thinking can not be as convoluted, maybe. Yeah, but basically you have 2 points, both these palms, and you subtract. You can do any of them since it's squaring. Basically, the actual number won't change because of how it's calculated with being the square of the difference. So negative or positive. In this case, I did negative. It's negative 2 squared plus negative 2 squared plus 1 squared. But if it was 2 squared plus 2 squared plus negative 1 squared, it'd be the same result. You get 3. So it's based off this formula here in 3 dimensions. A very similar formula is used for 2-dimensional distance between 2D coordinates on the xy plane. And the same thing here. Yeah, you just need to know the formula for this one. And that should be 2 squared root of 3, but it's shown on here anyway, so it's not big. Here's one a little bit more math as well, some simple thing. You know the standard equation of a sphere here. You want to find center and radius of a sphere, you basically put it in the standard form. And this one was already done conveniently for us. This is how it's given. So the center is square root of, remember, you're subtracting x0, y0. These are subtractions. Minus square root of 2 means it's square root of 2. Square root of 2 plus square root of 2 means negative square root of 2, because that's how the formula works. You subtract a negative, you get a positive, which is what happens here. Minus and minus, it's actually negative square root of 2. A squared equals 2 implies that the actual radius is square root of 2. Because it's, a is the same as a squared is what's given. And here, find equation for sphere with the relevant radius and center. Yeah, you're given the center radius, square root of radius, you get 14, and you basically do x minus 1, y minus 2, z minus 3, and all squared, of course, as it's shown in certain form, and it's equal to 14. But yeah, bam, but yeah. So find the centers and radii of the spheres in the following examples. So these last two problems for this topic, we basically have x squared plus 1, we given this equation, c squared, basically equal to 0. You have to complete the squares. Completing the square is what we do for the things to get you, and basically that means you add a proper square based on, to make it so you can factor eventually to get, this factorizations done. It's 2 in this one. But yeah, you base it x squared plus 4x, basically because you put them together, the ones that go together, like here's z squared and minus 4z. And of course y squared does not have this happen to it because it's by itself already, so we don't have to worry about that. As I said, y minus 0 would be the center for this one, so it doesn't. So you basically do half of this. You add half of this number in the middle. You add, x squared plus 4x, or z squared minus 4x or z. You add, this is a very good comparison. You still add it. Now, this sign is used in actual factor. So x squared plus 4x plus 2 squared becomes x plus 2 squared. Z squared minus 4z plus 2 squared becomes z minus 2 squared. And of course, you have to add these things. You're adding them to both sides, or else it doesn't work. So 0 plus 2 squared plus 2 squared. And that becomes right inside. Good? But yeah, the center now would be negative 2, 0, 2. And the radius is 2 square root of 2 because that's square root of 8. But yeah, negative 2, 0, and 2. And finally, this one, we want to get x squared and y squared and z squared to be basically in simple terms, like have a 1 in front of them basically. So x squared, for 2x squared becomes x squared. Basically, we have to divide by 2 on each side here. And this, it's still possible to do. We have to complete the squares again. We have to do it for all 3 this time, but this is the same type because it's all by, as you can tell, they're all the same. 1/2 is the thing now. The constant in front of the variables here, x, y, and z. So it's 1/4 because 1/2 divided by 2 is 1/4, and it's squared. We had a basic, it's still, simple algebra at the end of the day. So yeah, you add, you basically add plus 1/4, that's going to be, the center is going to be negative 1/4, negative 1/4, negative 1/4 is the constant. And the right hand side eventually becomes 75 over 16, which you have to take the square root of, and you get 5 square root of 3 divided by 4. So that's the radius, and there's the center. And that's it for the section.